So here's the complete data set. A 3D view. A station shooting across the roadway with a polygon framing. So you can see there are some spots where it picked up some passing cars, so we'll have to clean that out. And then my other station there across the other side, use that to get use both stations to shoot each side of the road. I got my curb. Right now I'm in an intensity based view. Then I can go into a station view and visualize everything using the panoramas that were taken. And then turn off my scans and just look at everything based off the photos for good site documentation purposes. Things such as this for lease sign, able to zoom way in and get some clear photos. Alright. And then we can process this panorama so that we blend the images together so it doesn't look like each of them are in a different exposure, and that will help that out quite a bit. Then we can also overlay the scans in a true color format. So we're actually looking at the scan data and the photo data. And we can zoom in on particular items that were scanned. And we can use a virtual DR mode within the station view and calculate coordinates on anything that we might have missed out in the field using our traditional survey workflow. So this is going to be very valuable for in the office use. So this is going to be a VR point. And I zoom into the object that I want to get coordinates on. Let's say I just want to get the edge of this letter C here. So we click on the area, then it brings up a pixel picker, so we can get right down to the exact pixel that we want to pick. Populates the northing, easting, and elevation for us. Hit the add button, and then we have a point on wherever we clicked. Now you can't really see that very well because it's on a white background. Let me choose something else here. Let's see, something that I have scan data and a photo on. That is the criteria in order to use this functionality. So maybe I'll choose something on this vehicle here that doesn't have a light background. We'll just do the edge of this light here. So maybe that's the pixel I want to pick. Okay. There's my coordinates. I'll hit the add button. There's my point there. So that will populate then on my plan view and my 3D view. You can see it there, right on the surface. So it's using the scan data as the surface or the depth / range, and then the angle or the georeferencing of the images in order to get the angle or the horizontal information. Okay, let's say that we want to draw in or draw in the line work for the center line of this road, or maybe the paint stripings, using TBC and the SX10 scan data. So from my plan view here, I'm going to start at this end of the job. I'm going to choose my line string tool from the CAD tab. And the name for this line string is going to be CL for center line. I'm going to put it on a road layer. I'm actually going to edit that road layer so that we have a different color. Okay, so I'll hit the OK button, and it'll bring me into my edit line string pane. And then right away we can go ahead and select the coordinates for our line string. So let's just say we want to start. Let's start right about here. We can be right in between a set of points. It's going to actually take the nearest point in the scan data, and we can draw in then our center line. Really easy. And you're getting X, Y, and Z coordinate when you're doing this. Alright, finish it off here. Okay, so I got my line string there. I can make any edits that I need to the nodes. I can add in a segment or delete a segment if I want to. I can also change the type of the segment. So if I was going around a curve, I do have either a smooth curve option, a best fit arc, arc or tangent arc, all of my options here for my segmenting. Okay, so hit the close button. That will finish my line string. Okay, let's see what that looks like in 3D view. Oh, say that looks pretty good. So then we can export that out as a DXF layer. Take a look at what it looks like in station view. As you can see there, it looks pretty good. Okay, so I've created my line string. Now let's say I want to use that line string to create a horizontal and vertical alignment. So what I can do is open up the corridor tab and choose create alignment. Okay, and over on the right side, I'll create my center line alignment name. I'll throw that on the roads layer. And then we have the option to define individual segments or use an existing line, and then we can populate which line we want to use. Okay, so we'll choose our center line string. We'll hit OK, and then it will automatically pull in all of that information for us. Okay, so then we have our stationing, northing, easting. If we go to our vertical tab, we have all our elevation information, our slope information. Okay, and then from here, we have that now in our project under the alignments drop down here, and we can easily export that then out as an RXL file or something else, a DXF, a DWG, whatever it might be, and go ahead and stake out that. Okay, now I'm going to go through the process of cleaning up a scan data set here. Since we have all this information over here that we don't really need, all we really want is the roadway here with the curb and road features. So what I can do is choose my polygon selection tool and draw in my selection using a polygon method. Okay. And just make that selection there. That looks good. Okay. Let's go into 3D view and just make sure that I got everything that I wanted. looks pretty good. You'll notice that I do have some scan data from the passing by of cars. We'll clean that up in a second. Go into the Point Clouds tab and click Create Region. So we're going to create a new region from that default entire region. That's how I guess that's how I can explain the scan data is organized in TBC. So let's say roadway for our scan region. Okay, and then in our View Filter Manager, we're going to have under our Point Cloud Regions section our default and our roadway. Okay, so if we turn off the default, we just have our roadway now. So just very easy to clean up your data set. Okay, and then we'll do a quick classify ground feature here in TBC to clean up the rest of that junk. Okay. Okay, given my roadway layer here, or my roadway region, I still want to clean up a lot of this parasite data from the passing by of vehicles. So the tool that we want to use under the Point Clouds tab is called Extract Ground. So we have to click on the region that we want to use to extract the ground from. So it goes through a process of extracting the ground and a series of algorithms to define just the ground. So you can see there what we have underneath is our ground, all in one color, and then our parasite data remains in that true color look. Okay, so now we have in our point cloud regions, we have our default, which is everything, our roadway, which we clipped out in a new region, which contained both the ground and parasite data. If we turn off roadway, now all we have is the ground. So we can simply work with the road surface and create a surface based off of this. Alright, so we're going to take our ground surface and actually create, I should say that's our ground scan data, and create a surface out of that. So what we can do is take the entire point cloud here of the ground and use our Create Surfaces tool to create that new surface. And then we need to select a member to form the surface, which is our ground region. Hit the apply button, and then this might take a little time. So what it's doing is it's using those millions of points, triangulating them and creating a surface out of it. Likely we don't need that many points to create the surface, but we can do it anyways. What we could do is sample down the surface very easily in the Point Clouds tab, and just use more of a sampled surface rather than the entire surface, or more of a sampled point cloud than the entire point cloud. So down at the bottom we're about 95% done with the new surface. Okay, so our surface is created. I'm going to go ahead and hide the point cloud so that we're just looking at the surface. And there we go. This is going to be our surface, very dense surface there because of all the points that we chose to use. but we do have it. All the flags are likely going to be points that there's going to be some sort of vertical tolerance or a vertex that was ignored because it was directly, I guess it says directly above another vertex. Just with the point cloud density, you're going to see that sometimes. But here's our surface. We can export that now as a TTM file and use that on our data collectors, or bring that in as a surface file into another program. I had mentioned sampling a point cloud, so since we don't need all this millions of points here, we can sample that point cloud very easily. There's a tool called Sample Region. And then from here we can give our output point cloud a name. So we'll say sample ground. We just need to select the region that we want to sample, and then there's two sampling types. A spatial will allow you to enter in a point spacing. Random will allow you to essentially extract out a number of points. So random will keep the definitive surfaces a little better than the spatial sampling. So if you have edges of buildings or curbs or things like that, random's going to hold those types of those definitions a little better than the spatial sampling. So what I'm going to do here is let's do maybe 250,000 points. The store button. Okay, so now we're working with something a little easier to create a surface out of. Alright, hit close, and then maybe your surface now can be made out of this. And then we go to surfaces, create surface, new surface, ground, sampled. Okay, hit apply. It's going to triangulate those points much faster than using the 100% of the points. Alright, there we go. Go ahead and hide the scan. And there's our surface. Go into a 3D view. See what that looks like. Much better. Okay. Alright, so I previously showed how to measure points using the virtual DR, which is going to be a very beneficial thing with the SX10. The other thing I want to show is just measuring a point. There's a couple ways to do this in TBC when we bring in the scan data. The first way is from the Point Clouds tab. We have this Measure Points tool. So that's what I have open here on the right hand side. We click in the point field and we zoom in. This is a tree. Alright, so I can get my XYZ information, the region it belongs to, and then the scan that it was captured in. So that was captured in my first scan, which used the control point 50. Alright, and then I have that information here. I can save that point. Then as let's just do tree 1. Save it on my points layer. Hit the save button. Okay. And then let's see, I'll do one more tree over here on the right. Alright, hit the save button. Tree 2. And it's just as easy as that. So what I'm going to do though now is show you the other way. I'll close out of, so that was the measure points tool. I can also use the CAD tool, create point, very similar to how we did in the virtual DR section. Let's look at the other side of the road here. We have some trees, just the bottom of the trees because of how I framed in the scan. So we got one here, 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 and here. So we can go ahead and type in our point ID, tree 3, on the points layer, and then we can also add in feature codes. So if we have a tree feature code, great. The coordinate type grid, and then our we'll click in the northing and easting box, or excuse me, just the northing box should do. Then we can click on point, get the northing, easting, and elevation information, hit add. There's tree 3, tree 4, and tree 5. Very easy there. Oh, forgot one there. Well, why not pick it up? Tree 6. Okay, so we have all that information on the trees there. So as fast as lightning, we can very simply shoot our trees using the scan data. Okay, when it comes to exporting our information now, we have a lot of options here. If we hit our export button, let's first export our point and line work. So this is going to be the information that we both created using the CAD and our information that was observed out in the field, our center line, our alignment, that information. Okay, so I'm just going to select that information here using my polygon selection tool. Okay, and then I can export that in various ways. We'll just do a CAD export. Let's do a DXF export. So we got our selected data. We're going to put that in our project folder here. I'm just going to make sure I've got the correct folder. Let's make an exports folder. And point, line work. Save. And then our settings. Hit the export button. And that's as simple as it is right there to export a DXF file. And if we look in the folder now, there's our DXF file. We can bring that into CAD or some other third-party software. Okay, so we're good with our point and line work. Let's go ahead and see what we can do as far as bringing or exporting our surface. Actually, tell you what, let's do our point cloud first. So let's export our default point cloud. Hit the export button, and then we have point cloud file format tab up top. Some of the most widely used point cloud formats or standardized formats include the E57 exporter and the LAS exporter for the most part. That's what we're seeing. So let's go ahead and do an E57 export. We'll select the points in the point cloud that we want to export. Let's just do this information for now. Okay. Do we want to sample points? And then based off the sampling, how many points we want to sample. Let's just go ahead and do all of it. I'm going to save that then to that export folder. Okay, export unit, and then we'll hit the export button. I can see this taking a little bit of time for it to essentially transfer the data or convert it to a different file format is what it's doing. Okay, so now that now we want to export our surface, and using the export tool under the construction tab we have Trimble Terrain Model Exporter. That's going to be the main way to export these surfaces. We also do have a land XML export. Okay, so what I'm going to do is a TTM export, choose the surface. We could choose a clipping boundary, so if we wanted a portion of the surface, choose where that's going to go. Okay, and hit export. And now if we look in our export folder, we have that ground surface, that Trimble tin model.